Hello, how you doing? I hope you're well. Before we get into the video, I want to give a little update. I filmed this in multiple pieces over probably the span of 3 weeks. And at the time that I'm recording this, last week, LA was hit with some unprecedented wildfires. Thankfully, I'm safe. My place is okay, but it was pretty scary for a bit and has been devastating for a lot of people. I've lived here almost my whole life. I grew up here, and I've been in awe of how LA has come together to support the families impacted by these fires. If you want to help somebody out, this is a link to a GoFundMe page dedicated to the wildfire victims. You can scroll through all their individual fundraisers and help them start to rebuild. If you have the means, I would really appreciate it. And now, we'll get into the episode. We are finally at the Quaternary Period, which started 2.6 million years ago and is still happening to this day. This is the time of the saber-toothed cats and the woolly mammoths, and this is also the story of us. Throughout this series, we've explored strange specimens that looked like aliens, alive 500 million years ago, the first animals on land, and the other unusual. Now, we are at the time of our species, the predators and prey that push them to become more social, problem-solving, and curious. So, without further ado, my name is Lindsay Nikole, and this is the history of life on Earth that we know of. Let's get the global conditions out of the way. We're gonna focus on the Pleistocene. You're familiar with the global conditions today, so let's focus on before. Which, by the way, the Pleistocene is like the Ice Age epic. You're probably most familiar with it as that. The epic we live in is the Holocene. So we have Pleistocene and Holocene epics. The Pleistocene being referred to as the Ice Age is a bit misleading for a couple of reasons, thanks to Hollywood and mainstream media. The term Ice Age refers to any period in Earth's history when temperatures are cold enough to allow glaciers and ice sheets to expand. During the Pleistocene, these conditions fluctuated drastically. It was a roller coaster ride of freezing glacial periods where ice could get to a mile thick. Then it would get warmer to around the global temperatures we have today. Then boom, back into the Ice Age. And then boom, back to the warm. And the climate went back and forth this way every 40,000 to 100,000 years throughout the Pleistocene, until a rapid warming at the end led us to our current epic, the Holocene. And I'll just say now, these natural changes are completely separate from the changes we're seeing in our climate today that are caused by humans, just so we all know what the fuck is going on. We're gonna get to that in a bit, but I will promise now that I will keep the vibes good. But like I said, the climate was bouncing around with glacial periods and interglacial periods in between. So it's worth mentioning that throughout the Pleistocene, interchanges kept happening. Remember the Great American Biotic Interchange, animal migrations across continents. So that kept happening, just keep that in mind. Everything is always in motion. Also, just like the climate of the time, we are also going to be bouncing around a little bit. There is structure, but some slight bouncing, just so you know. So now let's get into the animals of the Pleistocene, starting off with the final chapter of the terror birds, Psilopterus. Last time I mentioned the South American side of the lineage wasn't doing so hot, not far behind their relatives in the north. The youngest bones of this bird are about 96,000 years old, give or take 6,000 years. So, made it through the bulk of the Pleistocene, and then boom, a 60 million year old lineage was done so. But that is not the only large bird I have to show you. You've heard of owls. Matter of fact, you might like them a lot. If so, get this. A giant Cuban owl named Ornomegalonyx. Initially thought to be a terror bird because of its size when it was found in 1954. But then, in 1958, it got even better, i.e. is an owl. They got to about 3.5 feet tall, so not insane, but very much good friend size if you ask me. But paleo art has given them a much more sinister twist. They consistently look like something out of a fucking horror movie. Big, heinous, evil owl. But let me tell you more about it. It seems as though the size of Ornomegalonyx is the result of, you guessed it, island rule. I'm sure you already know what the fuck is going on. If not, island rule essentially means shit gets weird. The smaller an island is, the weirder it gets. The further it is from the mainland, the weirder it gets. Cuba is an island that today just so happens to be home to some of the best food on the planet. And in the past, home to giant prehistoric owls that had long and robust hind limbs and thick toes, armed with some of the most powerful claws of any owl to ever exist that we know of. We're gonna switch gears a lot and get to the elephants real quick. A couple of them. Like I said, we are bouncing around. Allow me to introduce you to Paleoloxodon, also known as the straight-tusked elephant, an absolute beefcake. They got to about 14 feet tall just at the shoulder, making them some of the largest land mammals to ever exist that we know of. Right up there with Paraceratherium, who in my heart is still the largest, but it's literally impossible to say. I think most people are on the elephant side of the argument because it seems as though fully grown Paleoloxodon bulls could have been even bigger than we have fossil evidence of based on size proportions of elephants today from a paper from 2016. Possibly 17 feet tall at the shoulder and 10,000 pounds heavier than the largest Paraceratherium individuals. But we need more bones of them, but for now, it's Paraceratherium in my heart. We need a little bit more fossil evidence for me to be convinced to go to the other side. While this genus has some of the largest land mammals to ever exist that we know of, It also has some of the smallest that we know of. Yes, this is the Sicilian pygmy elephant that lived in what is now Sicily. Fossil evidence suggests they had a stature like wiener dogs, long torso and short legs, and they evolved from some of the largest land mammals ever. So, you know where I'm going with this. Yes, island rule strikes once again. It seems as though a population of straight-tusked elephants migrated to Sicily over land bridge and eventually got isolated there when the land bridge disappeared. And they shrunk to shit over a long period of time, but it was relatively quick considering how drastic it was. From a 14-ton beast to a little guy the size of a Shetland pony. 15% of their ancestors' original weight. Depending on when exactly they migrated to Sicily, sometime between 175,000 and 50,000 years ago. This could have happened in as little as 40 generations, which is just insane. This size difference in that small of a window of time is nuts. Island rule, you take my breath away once again. There's probably a couple other proboscideans from the Pleistocene that you can think of right off the bat. Like I said, we're bouncing around. So for now, I'm gonna mention the most obvious for a second, get back to the rest later. The woolly mammoth, the icon of the Ice Age. They got to about 10 feet tall and weighed up to 13,000 pounds. They were found all over North America and Eurasia. These mammoths were perfectly adapted to handle colder climates with 2 layers of thick fur for insulation and smaller ears to reduce heat loss. But probably their most iconic feature is the set of tusks that could get to 16 feet long. Huge, and not for nothing. They played a big role in their lifestyle, possibly helping with defense and digging for food. Mammoths like to eat nuts, leaves, berries, fruits, twigs, a very cozy diet if you ask me. They had 4 massive molars to process this plant material. Aside from their looks, woolly mammoths are probably the icons that they are today because of their prehistoric relationship with humans. They were the muses of early cave painters in Europe, and a great source of meat and material for multiple human species, who used their tusks and bones to make tools and construct humble abodes. Probably the weirdest aspect of this relationship is the fact that you could argue it's still going on to this day. The mammoths have been extinct for thousands of years, but as you probably know, Colossal is working to de-extinct them, which is a video topic I've been putting off for far too long. This series took over my whole life, so now, after this, I'm gonna have more time to cover stuff like that. De-extinction is super controversial, but I think I'm gonna give you a unique perspective on it because I do communicate with the company a lot. I'm also on their youth advisory board, which means I hear about the projects they're working on directly from them. I'm able to give feedback on them and sometimes get involved, which is absolutely sick. The technology they're creating to de-extinct the mammoth is going to be used in a much broader range of ways. Very cool ones. So, stay tuned for that. To de-extinct an animal, you need to have viable DNA, which is obviously very hard to find in animals that have been gone for thousands of years, and cannot be done for animals that have been extinct for millions of years. By the way, Jurassic Park cannot be a thing. Anyway, scientists have been able to extract it from individuals found frozen in ice from thousands of years ago, which sounds like the plot of a movie. One of the most well-preserved mammoths found so far is named Yucca, found in 2010 in Russia. It was dated to about 39,000 years old. It was somewhere between 6 to 9 years old when it died. 6 to 9. Not 69, 629. Yucca's brain was surprisingly intact and was able to be CT scanned to compare it to the brains of African elephants. And what do you know? They were extremely similar. So they probably had a lot of the same behavior patterns, maybe able to use some level of tools like elephants can today. Another animal that's been found frozen in ice is the woolly rhino, which we talked about last time, but is definitely most known as a Pleistocene persona. I was trying to get some alliteration with that. I don't think I did a very good job. Anyway, in 2020, a woolly rhino was found in Russia. It was dated to about 32,000 years old. It had soft tissues, skin, and wool, and also a fatty hump. That was a previously unknown characteristic. That's sick, dude. The world is nuts. You have an idea based on the bones of an animal, then boom, one gets washed up from the depths of permafrost. And what do you know? It has a hump. They were found throughout Eurasia, didn't make it to North America, that we know of, and that's all on them for now. By the way, now we're in ungulates. Woolly rhino was the first one. The next two are weirdly grouped together because they were both collected by Darwin on his Beagle voyage, and they were both found in Argentina. Point for Gian. They also both had a combination of weird features that made it really difficult to place them in the mammalian tree for a while. But thanks to big tech, they were both eventually determined to be most closely related to perissodactyls, i.e. the odd-toed ungulates. They are Toxodon and Macrauchenia, the Argentinian misfits. Let's start with Toxodon, a big-bodied, hoofed mammal with a variety of traits. Darwin himself wrote, Toxodon is perhaps one of the strangest animals ever discovered. Why did he say this? Well, Toxodon had curved incisors like a rodent, eyes and nostrils further up on the skull like a manatee. It kind of looked like a cross between a hornless rhino and a hippo, and this left scientists stumped for almost 200 years. It was also once described as a giant guinea pig built like a short-legged rhinoceros with hippo-like habits. Quite a mouthful. It was thought to be semi-aquatic at one point. That ended up not being the case. But, like I said, they were determined to be most closely related to the group that includes rhinos, which checks out. And Macrauchenia. They had a different combo of unusual features. As you can see, they had a body similar to a camel without the hump, a long neck, and potentially a small trunk like a tapir or elephant. I say potentially because some scientists don't like that idea. But Macrauchenia's nasal aperture, the nose hole, sat right between its eyes instead of lower down the snout, which is similar to that of elephants and tapirs. So this placement suggests maybe a trunk, but that's the only connection. There's no soft tissue evidence, no perceived muscle attachments for a trunk. So maybe it looked more like a saiga or a moose, who knows? The case is not closed. The last few Pleistocene ungulates on the list were all just juiced the fuck up. Starting off with a hippo. Oh, I know, you're telling me hippos aren't already juiced up? That's exactly what I'm telling you. Allow me to introduce you to hippopotamus gorgops, who got to about 2,000 pounds larger than hippos alive today. I don't think I have to paint a picture of how hellish this beast would have been on the banks of North Africa. No thank you. Next, the Irish elk. Not an elk, but a deer. The largest deer, to be exact, that we know of. They were 7 feet tall at the shoulder, and males had antlers with a span of up to 12 feet. The length of my room, just pure antler. As you would expect, the males use these massive antlers to attract the ladies. For a long time, they were used as an example of reproductive selection gone haywire, going too far in the sexy direction, and it made getting around miserable, fleeing from predators nearly impossible. And I get it, those are some sexy ass antlers, but they were so sexy it killed them. Sad. At least that was the idea for a while. They were a great example of reproductive selection in classrooms across the globe for a long time, but more recent evidence suggests their extinction was actually just caused by the shifting climate. Caused their food to disappear. And so they disappeared too, which sucks, because death by being too hot seems like the ideal way to go. All right, next, you know moose. I hate that the plural of moose is just moose. I wish it was meese. You know meese. Fuck you, grammar monster. They're massive. They're so big, and many people don't realize it. But get this, there was one even bigger alive in the Pleistocene, the broad-fronted moose. Their antlers were so big, 8 feet wide. The scientists think they would have been too heavy to use in any productive way. No fighting, no defense, just surface-level bullshit. And last, the African long-horned buffalo. Their horns spanned over 10 feet wide. Outrageous. They were initially thought to be a long-horned morph of today's Cape buffalo, but further research on their teeth and horns and geographic range determined that they are two separate species that did live alongside each other in some areas. Maybe got confused and mated a bit. There's no direct evidence of that as of right now. We're switching gears again. We're gonna start to get into the predators of the ice, the carnivorans. Aside from the woolly mammoth, I would argue the most iconic members of the Ice Age fauna are all carnivorans. Most of them are carnivorans, and there's a shit ton of them. So let's get this show on the road. Starting off with one of my favorites, the American cheetah. When people say North America used to look like an African savanna, they fucking mean it. Despite their name, they weren't actually cheetahs. Their closest living relative is the puma, also closely related to cheetahs, but not cheetahs themselves. A bit confusing, I know. Because of this, the American cheetah has gone through the ringer, classification and reclassification over the years because of their particular mix of traits. Compared to pumas, the American cheetah had a pretty small head, long, slender limbs, and smaller canines. Seemingly cheetah things, so initially they were classified as such, in the same genus as modern cheetahs. But it turns out this was just another classic case of convergent evolution. At about 150 pounds, the American cheetah was a formidable predator. Their cheetah-like frame suggests they were perfectly adapted for pursuing prey. Across the prairies of North America, hunting pronghorns, which are fast as fuck. Turns out they made up about 40% of their diet in some areas. But also, new evidence is suggesting their habitats were more diverse than that. Some American cheetah fossils have been found in what would have been more rocky and cliffy terrain, suggesting that some of them lived a lifestyle more similar to snow leopards, hopping all over the cliffs, which is pretty sick. This cat could do it all. Now we're gonna bounce over to Europe real quick, where I can introduce you to the cave bear. Their remains have been found in, you guessed it, caves in Europe. They were thick and heavily built, getting to the size of polar bears alive today. And actually, as I'm saying this right now, I realized putting them on the list after I said predators of the ice was fucked up because these were not predators. These tanks ate plants, full-on vegans, and they must have eaten a lot of plants to stay bulked up like that. They were first described in 1794, but their remains have been found in caves for hundreds of years before that, back in the Middle Ages. Do you know where I'm going with this? Guess what people thought their skulls were? Yes, ding ding ding, the skulls of dragons. They wanted dragons so bad, and I get that. The Middle Ages were only like 20 generations ago, by the way. I looked it up because I got curious. That's kind of crazy. That doesn't feel like a lot, but the year 1500 sounds like a really long time ago. Anyway, turns out cave bears were also the muses of some early humans, which really makes you wonder what kind of stories they had about encountering them. Probably horrific ones. I'm personally glad we do not live in caves today, because they were not the only cave carnivore to look out for. Europe had cave lions too, the largest of which were some of the biggest cats to ever exist that we know of. And this time, a full-fledged carnivore that might have primarily stolen their food from other cats, like Homo because they were so big. They were the head honchos. Their size let them do whatever they want, get food served on a silver platter. Aside from the fact that early humans were making art of them too. Cave paintings, even some of the earliest figurines in the world. Lion Man figurine, this dates to 40,000 years ago. Cave lions are also extremely cool because of some mummies. Yes, more mummies that were found in Russia. Between 2015 and 2018, 4 cave lion cubs were found frozen in ice. One of them was named Boris, a male cub. He was dated to 43,000 years old. Another one was named Sparta, a female, 28,000 years old. Based on analyzing their teeth, both of them were 1 to 2 months old when they died. And like the Homo cub I mentioned last time, these cubs were compared developmentally to a modern lion cub of the same age. It seems as though cave lions developed faster than modern lions. They also had lighter fur, both likely adaptations to the colder and harsher climate of the time. And it probably won't surprise you to find out that yet another continent had their own version of a lion, and this time completely made from scratch. Take a guess. Yes, Australia. Allow me to introduce you to the marsupial lion. Not lions, but marsupials with a pouch. Yet another classic case of convergent evolution at work. Actually, catanization at work. The marsupial lion looked like a fucking cat. It had retractable claws like a cat, and a bite force similar to, or potentially even greater than, a true modern lion. But their tail was more similar to that of a kangaroo. And their teeth alone will tell you this is not a cat. This is instead some kind of sick joke. They looked like a carnivorous rodent. Fossil evidence suggests they likely spent some time in the trees. At about the size of a modern lioness, they are the largest carnivorous mammal to ever exist in Australia, that we know of. At the same time, there was a lizard on the continent that got even bigger. We're doing a little detour into Australia real quick. This is again another bouncing around. Megalania, the largest terrestrial lizard ever that we know of. They got up to 22 feet long and weighed up to 4,400 pounds. A massive reptilian beast. And as if that's not enough, they were possibly venomous, like their modern relative, the Komodo dragon. So what kind of items were on the menu for a lizard this big? And for the marsupial lion as well? I have a couple prey species to introduce you to. So, you know, wombats, those marsupials that you just want to... So they can get pretty big. Not a lot of people realize how big they can get. They can get to almost 90 pounds, which is awesome. That is so much wombat. But now, imagine if they got to the size of a rhino. Well, you're in luck. They did. This is Diprotodon, the largest marsupial to ever exist that we know of. They could get to 12 feet long and 6 feet tall at the shoulder. And they were a beastly relative to the modern wombats and koalas. And just like most other marsupials, they had a pouch, just like kangaroos, but on a rhino-sized wombat. What an image. And speaking of kangaroos, of course Australia had a hellish kangaroo in the Pleistocene, the short-faced kangaroo. At first glance, you might think hellish is a little dramatic, until I show you their foot. Guess how many toes they had on each foot? Guess. They had one single toe on each foot. That is diabolical if you ask me. They also got to 6.5 feet tall, making them the largest hopping animal to ever exist that we know of. I love that we have that as a record. A quick little update I want to do real quick is in Xenarthra, which had Pleistocene icons like the giant ground sloths and the Glyptodonts. Last time I hinted at a Pleistocene Glyptodont with a weapon for a tail, the Dicarus, a 12-foot long Glyptodont that had a tail club that alone could get to 140 pounds. The tail club alone, capable of delivering painful blows in ritual combat for territory and also mates. Back in 2009, researchers applied methods used in sports equipment analysis to figure out if they had a sweet spot on the club, just like a golf club or a baseball bat, which in sports is described as a spot that delivers maximum power, but produces the least amount of force in the athlete's wrist and arm, reducing the chance of injury. And they figured out that they did. And right at that sweet spot were where the largest spikes project out. Yes, evolution at work. The rest of Xenarthra, I'll do in a little bit. For now, we're moving on to a giant rodent, Castorides, a beaver that potentially got to the size of a fucking black bear. Unfortunately, as of right now, there's no evidence that Castorides got into the same shenanigans that their modern relatives did, building dams, cutting down trees, etc., which is sad. But I hope that makes you that much more appreciative of beavers alive today. We have rodents alive today that construct homes with full-on tree wood that they chop down themselves, then bring to make a house in the water, and make beaver freezers to store food for the winter. That's cool. You know what? I want to make it a goal to see a beaver dam in the flesh this year. I've never seen one, and that was my college mascot. Isn't that just horrific? I was an OSU beaver, and I've never seen a beaver dam. I don't think I've ever seen a beaver in real life. Damn. Anyway, I'm making the giant beaver out to be not shit. That's obviously not cool. A giant beaver is cool. And they also spent most of their time in the water. You know what? I am gonna say it to make a point I feel like I can't often make. These beavers weren't shit compared to the ones alive today. Beavers today are much cooler than prehistoric beavers. Take that, prehistory. Take that, deep time. One of the most captivating aspects of the Pleistocene is the evolution of our ancestors and the interactions they had with some of these prehistoric beasts. I want to introduce you to a couple other cool apes that were no homo. Starting off with the biggest of them all, Gigantopithecus, the largest ape to ever exist that we know of. I've talked about them a lot because look at them. They were twice the size of modern gorillas and weighed up to 1,000 pounds. And their discovery is very interesting. I did a whole video about it. They were found in what is now China. One of the weirdest aspects of their discovered remains is that it's a shit ton of teeth, thousands of teeth, and just a couple mandibles, nothing else. And it seems as though part of the reason is that porcupines ate the bones. They love them. They crave them. They consume them for minerals to maintain their lovely quills. That's just what they got going on in this region. But luckily, as we all very much know by now, there's a lot scientists can figure out about an animal from teeth. Gigantopithecus liked fruits and also dabbled in leaves, stems, and possibly bamboo. Throughout the about 2 million years the apes were around, over time, their teeth got bigger and more complex, probably in response to the Pleistocene ice fluctuations. And those teeth are the biggest primate teeth ever found. So boom, big ass ape, King Kong IRL. Now we're moving into the hominin lineage, but not Homo just yet. Remember last time, Erica talked about Ardipithecus and then Australopithecus. During the Pleistocene, a group of hominins emerged that were unlike any others alive at the time. They were part of a genus called Paranthropus, also known as the robust hominins, because of their robust features. They had thick cheekbones and brow ridges, massive thick jaws and molars, and this bony mohawk ridge called a sagittal crest. All features that formed strong muscle attachments for a powerful bite, allowing them to chew on tough and fibrous foods like grasses, nuts, and roots, and possibly, occasionally, meat. Remember that for a second. Over 300 fossils have been found and identified as Paranthropus remains, categorized into 3 different species. Paranthropus ethiopithecus, the oldest and most mysterious of the 3, found in eastern Africa. Paranthropus robustus, who possibly used bones as tools to dig termites out of termite mounds, found in southern Africa. And Paranthropus boisei, who had the most extreme characteristics. Very large molars, very dish-shaped face, very thick dental enamel, also found in eastern Africa. Although this lineage eventually died out, it's possible they left something to carry on their legacy, and you're not gonna like it. Genital herpes, which infected the hominin lineage sometime between 3 million and 1.4 million years ago, from a chimpanzee ancestor that was alive at the same time and in the same region as Paranthropus boisei. More research is needed, but it's possible Paranthropus ate infected ancestral chimp meat and passed it to our ancestor in Homo in a similar fashion. Which brings us to our genus, Homo. Probably the most disrespectful transition I could have done. Just kind of starting off on a bad note, but it is what it is. Let me just say now, of all groups and developments we have talked about in this series, this one is the most deserving of its own spin-off. The story of how we went from worrying about bears in caves to having your biggest worry be why she's not texting you back is complex, to say the least. The fossil record has provided many answers, but is also very hard to untangle. Transitional fossils that fit in between 2 species, intersections of multiple human species, and so much of our development can't be easily understood from bones. How can we define our consciousness? What was the role of religion in early human groups? There are a lot of ideas out there, and new ones are being added all the fucking time, and I have only dipped my toes into it. And so, I'm sure I don't need to, but I'm going to reiterate. What I'm about to talk about is not even a snapshot. It's a couple pixels of our genus. If you want to go deeper into it after this video, a really good place to start is the Smithsonian's Human Origins website. They have tons of interactive tools, lots of easily digestible information. It's humanorigins.si.edu. I'm going to put it in the description too. Now, starting off with the base of our genus in the early Pleistocene. A few things made them stand out from other earlier hominins. Obligate bipedalism, meaning they didn't spend any time on all fours. They had taller and leaner bodies, larger brains, flatter faces, and an increased reliance on culture, like tools, very simple tools like hammerstones, that were developed in earlier hominins and at this point were a key part of their ability to survive. Some of these early humans included Homo habilis, Homo rudolfensis, and our ancestor, Homo erectus. Don't. Dude, if you're trying to convince someone that human evolution is a thing and you tell them about Homo erectus, they immediately think you're fucking with them. It becomes a certified joke. I know that plenty from my TikTok comments. Is it childish? Do they have the brains of a child? Yes, but it is not helping. And it's a shame, because the reality is Homo erectus was unbelievably significant for the evolution of our genus. They first appeared about 2 million years ago in Africa and existed for over 1.5 million years. So like 5 times the amount of time that Homo sapiens have existed, by the way. During this time, they learned how to control fire, allowing them to cook meat, possibly a reason why our brains got bigger. They also made more sophisticated stone tools, like an Acheulean hand axe. And they were the first hominins to migrate out of Africa. And they spread the fuck out, with populations settling all throughout this range, and eventually evolved into new species, including us, Neanderthals, Denisovans, and the Hobbit people. Let's start with the most intriguing species on the list, the Hobbit people. Their scientific name is Homo Floresiensis, and they're the smallest human species to ever exist, that we know of. Hence the nickname, the Hobbit people. They were little. They were small. They were 3.5 feet tall and weighed somewhere between 35 to 80 pounds. They were alive until about 50,000 years ago. All their fossil remains come from a cave on the island of Flores in Indonesia. And so, they seem to be another classic case of island rule. Along with their remains, scientists have found stone tools and fossils of other animals, like pygmy elephants, which the hobbits seem to have hunted frequently, and giant rats, another island delicacy. The hobbits also probably used these tools to defend themselves against predators, like giant Komodo dragons, which might have ate them a little bit, and giant storks, who might have eaten baby hobbits. Whether or not they interacted with other human species, including our own, is unknown for now. It's been hypothesized that our ancestors were the reason for their extinction, but there is no hard evidence that they interacted at all. But that is absolutely not true for the next 2 species on the list. The evidence might exist in your own DNA, starting off with Neanderthals, alive until about 30,000 years ago and found throughout Europe, the Middle East, and Western Asia. They were bulkier than Homo sapiens with broad chests and more protruding foreheads, which might make you tempted to think of Neanderthals like this. They were actually a pretty advanced species that made art, cared for the elderly, and potentially had burial practices, just like our ancestors who lived with them for thousands of years, somewhere around here. And shit got weird, and now many people today have 1 to 4% Neanderthal DNA. There were also the Denisovans, who were found in Siberia and Southeast Asia until about 30,000 years ago, maybe 15,000 years ago, possibly. There have been very few fossils found of them, but we know a lot of them from extracted DNA. And what do you know? Shit got weird with them too. And now some people alive today have 3 to 5% Denisovan DNA. Homo sapiens obviously met these other species by migrating to shit. We originated in Africa about 300,000 years ago, possibly earlier. And some groups were on the move very soon after that. We've always been very curious explorers and continued to advance culturally over time, developing more sophisticated stone tools like spears and scrapers, and started to test out other materials like ivory and antlers. Early Homo sapiens made more personalized jewelry, made paintings and figurines to reflect the world around them, musical instruments. And our natural curiosities allowed these innovations to start snowballing in advancements. But at least 40,000 years ago, humans started fishing, and not the rod and the fishing line we know today, just yet. Probably just catching fish by hand, maybe using really simple tools. This obviously snowballed as well, and eventually split off into 2 main categories: fishing for food and fishing for fun. And today's sponsor lets you do the latter anywhere you go. Fishing Clash, the multiplayer fishing game where you get to reel in all kinds of fish from all over the world. It goes beyond the typical fishing game, allowing you to cast your line in stunning real-world locations, recreated to let you explore the natural world, from the Florida coast to Lake Biwa, and even exotic locations like the Galapagos and Loch Ness. Fishing Clash transports you to some of the most coveted fishing spots on the planet, while reeling in some of the most unique fish from those locations. You'll be able to learn about their habitats along the way, which is an aspect of the game that I like a lot. I feel like you don't expect to get that with other fishing games. But this next part, I think, is the coolest. You also have the opportunity to participate in virtual events that promote sustainability and conservation. Like last year, the New Zealand cleanup event raised funds for a group that monitors the number of microplastics in New Zealand's waterways. The year before, players helped to plant 60,000 trees just by playing the game. That's so cool. This is more than just an app. You get to be part of a community that values and supports environmental causes. You get to learn about cool fish, and you also get to fish them. How sick is that? But that's not all, because Fishing Clash is offering a special deal to you, i.e. a viewer of this channel. You can use this special gift code to claim a $20 value reward, including a unique avatar for free. Download the game using my link in the description box, or scan the QR code displayed on the screen. Thank you, Fishing Clash, for sponsoring this video. Now, back to the early humans who started fishing in the first place. They were interacting with and manipulating their environments in ways more complex than any other animals that we know. Group sizes increased, allowing for more complex social interactions, like division of labor, more sophisticated resource share, and eventually, at least 15,000 years ago, they developed a new control of the environment around them: domestication. It seems to have started with wolves. By the way, probably gonna do a more in-depth video on domestication of wolves and cats next year. By a few thousand years later, humans realized they had control over the growth of plants as well. Things like figs, grasses, squash, that are key components of lovely recipes that could be grown right in the comfort of their own backyard with the right care. The agricultural revolution was upon us, at different rates in different populations. And right around that time, the rest of the world was shifting. The Pleistocene was coming to an end, and the world was about to enter a time with more stable climate. That's right, bitches. We're at the tar pits. You say it, you say it.
Oh.
We're gonna be walking in.
Wait, I'm not ready.
Okay. All right, we're gonna go.
Wait.
You said okay. Today we're gonna check out the tar pits, check out the collection.
I'm sorry to interrupt you. There's a man looking right at us. Who is that man? What?
Oh, that's not any man. That's Miniminuteman.
Oh. Yeah, it is.
You see the point where I start running? Who would have thought that you'd have to film a walk-on shot like 4 times?
Well, now I don't know who to look at. Jesus Christ.
What's going on YouTube?
All right, that's right, bitches. We are at the tar pits with Milo. That's right, bitches. We are at the tar pits with Milo, also known as Miniminuteman. You know him, you love him. We are here in LA. He's here in LA.
I'm here in LA.
What the fuck?
In person, physically, right here, standing right now.
Yes.
I'm Milo Rossi in LA.
Tell us more about you, Milo.
How's it going, everybody? I am another creator here on YouTube, focusing primarily in archaeology and natural history. Lindsay and I have worked together before on some things. In fact, we both kind of had a similar trajectory starting out on YouTube and things like that, so I kind of feel, you know, that kinship there. And today, for the first time, we're actually together in person, filming at the La Brea Tar Pit. So as you're seeing here, we are working on Lindsay's History of Life on Earth as We Know series, and I'm gonna be making a video focusing a little bit more on the history of La Brea Tar Pits as a whole, which will be over on my channel, which you can find at Miniminuteman or Milo Rossi. I'm sure there'll be a link to that somewhere.
Yes.
Yes.
We're looking at a tar pit with bones in it and liquid on top.
Bones and liquid on top. I don't think too about that.
Pause!
So Emily, how many fossils are in here? Like how many bones?
Well, so we think, around 4 to 5 million fossils. Only about 600,000 of those are fully cataloged and digitized. And this is our primary range, which is like our best curated section of the collection. So within here, I don't know, 500,000 to a million, maybe? I don't know.
There's just so many. Yeah, look, it's just like...
Any drawer you pull out, most of this aisle is just direwolf skulls.
Jesus.
Whoa!
There's 400 outside.
Wow.
Yeah, and you know, we have so many direwolves, we don't even keep the rest of the body in this part of the collection. It's just
Wow. Oh my God.
That's nuts.
they're arranged by pet, right? So these are
You like that one?
but
Lindsay, would you call this a bone zone?
I would definitely call this is a mega bone zone.
I think we're extinct. The direwolves?
Lindsay might know that. Lindsay, why did the direwolves go extinct?
I don't know.
Come on, man.
What did you do, Lindsay?
What have you been doing?
I haven't finished research yet.
You know, here at La Brea, there's this really interesting intersection of significant climate warming that coincided exactly with the timing of rising human populations on the landscape. And we see 100% of the extinctions of these large animals in this region happening right at that time, in that like 300-year interval of really elevated fires following this 2,000-year episode of significant warming and drying and the rise of human populations.
Evolution at its
That
finest.
was the apex predator of then. This is the apex predator of today.
These are like saber-toothed cat ankle bones, and they just, you know, stack so nicely in there.
It's making me like, I think I have a little OCD and it's making me so happy seeing them organized like this.
Absolutely, yeah.
It's definitely very satisfying.
Yeah.
Smile at our skills.
Wow.
Dude. Yes.
because it got stuck here. And that's the amazing thing. Like this, like a lot of museums you go to and they have cool stuff, but it's stuff they went somewhere else and like dug it up and brought it back. Everything we have here is, with the exception of like the modern comparative collection, is like a fossil that was dug up right here in this park.
Unbelievable.
That's pretty rare for a museum.
That is.
Look at that kid on the floor.
Oh, don't film the kid. Don't film the kid.
I can't walk around there safely. I would ruin my shoes too badly. Can I touch it? Absolutely.
This is the real reason you came back to the tar pits. Yeah. That's crazy.
There he goes.
Wow, that is bizarre.
Yeah.
Wait, I want to do it too.
All right, you can do it.
Nice.
Yeah, would not want to fall in that. That's
No, I think I'd get stuck in that.
this guy.
This is a Colombian mammoth.
Wow.
So our largest species of mammal that we have here at the Tropics, the Colombian mammoth. So we have an extremely large collection. We have around 3.5 million specimens in our collection. But we only have 35 Colombian mammoth individuals. And this is a really unique and special one because of the 35 skulls that we have, this is the only one that's really yielded both tusks. You're welcome to feel here. Do you feel how smooth it is down here? Yeah, please, go ahead.
Wow, that is like.
And if you move further up the tooth, do you feel the more pronounced the ridges are?
Yeah, that's crazy.
So that's showing us wear and tear on the tooth from chewing, same as you would see on car tires or on our shoes.
Wow.
So this area has been exposed to most of the chewing, that's why it's got a smooth surface. This area still has a lot of thread on it to do the chewing. And then over here in the back, that dentine hasn't worn down yet to start exposing that.
Wow.
These are his shoulder blades here. They still got asphalt dripping out.
Oh my gosh.
Look at that.
It's cool in here, so it's not very sticky, but if you put your finger on it and like leave it there for 10 seconds, the heat from your finger will start to melt it and you can like leave a little fingerprint in it.
Oh, wow.
But it's kind of cool.
That's just like dripping out of the bone.
Dripping, These are femurs of giant sloths.
Whoa.
Like, like Kaiba.
No way. Dude, what?
Oh my god. Can you guys both hit that pose? Can you just hit that? Yeah.
But our lab is a very unique lab, the only lab in the world that does asphaltic fossil preparation. We have to dissolve and soften the oil so that we can remove it from the specimen. So if you want to, I can show you over here. This is the top of a bison skull. This is usually what it looks like. You can see a little bit of that brown bone underneath it. And then this is what we call matrix. So matrix is sediment, the sand, the rocks, the pebbles, and any other biological organic material that got enclosed and encased in this preservation. And so that matrix is what we try and remove. And we do this very carefully. We use degreasing solvent called Novex 73DE. So I've just dipped it in there, and let's look at that area. And do you see what it does is it almost instantaneously liquefies the asphalt. Do you see how the tool is absorbing it and it's becoming darker and darker in color?
Wow.
It's like nail polish.
Exactly.
Yeah, really.
And we do actually use nail polish remover here in the lab as well.
Touch where I wear it, right there. Wait, right here? Yeah. Oh my gosh. That's crazy.
Yeah, it's like putty. That's so weird.
Yeah.
Wow.
You're absolutely wicked.
Wicked, bruv.
I'm ready.
Which is also why, like,
Oh my god.
She's crazy. She's doing both feet. She's lost it. Are you gonna do both feet, Lindsay? Daring.
Here's all the matrix we removed.
Oh, so you keep that
Yes,
with it.
we keep it. And so what we do is once we finish the preparation of all these specimens that you see around you, We come back and we harvest all the matrix associated with these deposits. We then put it in a vat of solvent to remove the asphalt, and then can take it over to the microscope and sort for microfossil material over there.
This seems fake to me, you know? Like, it doesn't seem...
I don't believe it.
Fake bison?
I don't buy it. Yeah.
I like to say when in the lab that all sizes matter. So not just Z, which you could trip over, but also these little microfossils, the little things that if you look at it, it just looks like pieces of dirt. When you look at it under the microscope, you can see exactly what it is.
Are you sorting through the fossils?
I am sorting. This is what it looks like, right? But when you put it under the microscope, you can tell what part is sediment, what part is bone, what part goes with plants.
Wow, that's amazing.
What parts are insect parts,
Wow.
and then we get shells too, parts of shell as well, which gives another piece of information about this area, which is quite fascinating. Then of course there's always a part that you don't recognize.
The mysteries.
So that goes here.
All right, now it's time to go. Send me back.
No!
Whoa, what a trip. And I came back with this. So sick. Let me put it. Yeah. I personally can't believe that the museum had this for sale for as little as it was. Like half the price of ones you could find online. So I'm stoked. I gotta figure out how to put this somehow into the setup. It's really big. I don't know how I'm gonna put it on the wall, but I'll figure it out. I've been looking at stuff like that for like 3 years, and now I have one, and I'm very excited. Okay, and now, after a quick detour, we have reached the Holocene epoch, which marks the end of the last ice age and the extinction of many Pleistocene megafauna. The only real difference between the animals that exist today and the ones that existed in the ice age are the ones that went extinct during the ice age. Every animal on this planet alive today was alive during the Pleistocene. Wasn't that long ago. The reason why the woolly mammoths and the woolly rhinos, the saber-toothed cats, the glyptodonts, etc. went extinct is generally thought to be due to either climate change, disrupting resources at the time, or the arrival of Homo sapiens to a region, or a weird mix of both. To keep it simple, we're gonna leave it at that. But the Holocene also marks the start of human development in a new direction, with the emergence of agriculture for hundreds of millions of years. Actually, no, more than that, for billions of years. An organism's environment has shaped the organism itself, and its species lineage. And while yes, that organism, in turn, shaped the environment around it, it only did so to the extent that the environment allowed it to. The carrying capacity, the checks and balances of nature. The agricultural revolution was the first time the control has been flipped, ever, in the history of life that we know of. Homo sapiens suddenly had the power to manipulate their surroundings and create a fully regenerative food supply, which means the carrying capacity for us was starting to dissolve. And the checks and balances didn't necessarily apply. Agriculture made life a lot more comfortable and stable, very cozy to an extent. So our understanding of community and social structure completely changed. Our populations were beginning to rise, and we continued to find new ways to use our environment to our benefit. Societies turned into civilizations, which evolved culturally in really unique ways. Some civilizations turned into empires, which had control over even more resources, on a scale the world had never seen before. And now this becomes a whole different topic. This becomes a history class rather than biology or paleontology class. That is personally not my thing. So now I can think of two ways to go through this epic: human development, empires, etc., or animals I haven't introduced you to yet that went extinct during the Holocene. I think you already know what the fuck I'm gonna pick. But you know what? I'm gonna do a tiny little mix. I'm gonna do them in chronological order and say one very generic thing about what humans were up to at the time that each animal went extinct, for context. I might be a little off on the human timeline. It's not my thing, but I'm gonna do my best. Let's get into it. All right. While many of the giant ground sloths met their demise around the time of the end of the Pleistocene, a couple species held on for another few thousand years. Allow me to introduce you to Megalochnus, a giant ground sloth that existed in Cuba until about 4,800 years ago. We're in the hundreds now. Fuck. During this time for humans, Bronze Age was in full swing. Stone was out. Bronze was in. The pyramids of Giza were starting to be built around this time, as well as Stonehenge. Another animal that went extinct during this time was Myotragus, also known as the mouse goat, that lived on Majorca in the Mediterranean Sea. And this is yet another case of shit getting weird as fuck on islands. The islands Myotragus inhabited seem to have been free of predators, which gave them the opportunity to go creative mode on evolution. They developed more forward-facing eyes, typically a predator thing, extremely unsettling on the mouse goat. They also developed low gear locomotion. They moved very slow, really no running or jumping, or any urgency at all. As a lifestyle, don't need it. They also had reduced structures in their brains associated with sound, smell, and sight. Don't need them. But that didn't come in handy when the first Homo sapiens arrived on the islands, which seems to be the cause of their demise. Continuing our journey to the Holocene, we're going to go to another island, the much bigger island of Madagascar. Between the years of 0 to 1000 CE, we are now in the Common Era.
Is loving Jesus legal yet? No.
Obviously, throughout the years 0 to 1000, a lot of shit happened for humans. For example, Jesus. Quite a big impact on religion, the Roman Empire, the Middle Ages, medieval Europe. For Madagascar specifically, this was a time of visitors. Lots of them, mainly from Africa and Austronesia. They came in contact with a very cool group of animals that combine qualities of two fan favorites alive today. Do you like sloths? How about lemurs? Well, allow me to introduce you to the sloth lemurs. I am pissed they're not alive anymore. These primates had it all. Faces like sloths, bodies like lemurs, and all different sizes, different lifestyles, with groups like Mesopropithecus that were about the size of lemurs today. Archaeoindris, they got to the size of a gorilla. A lemur, the size of a fucking gorilla, dude. There was also Paleopropithecus, which had hook-like hands and feet, so definitely lived a life in the trees instead of the ground. All differently adapted to go after the same kind of diet. Fruits, leaves, and seeds. It seems as though these human visitors were the reason for their demise. Cave paintings discovered in 2020 show sloth lemurs being hunted by dogs and people. There are some bones that even show cut marks that seem to have been left by weapons. A couple other animals that went extinct in the region at the time. Megalodapus, also known as the koala lemur. Their feet looked like those of a koala, designed for climbing rather than leaping or walking like other lemurs. Also, the giant aye-aye, 2.5 to 5 times bigger than aye-ayes alive today. It seems like their teeth were used as jewelry, which I'm honestly shocked by because aye-ayes to me scream bad omen. If you're gonna think of an animal as a bad omen, you know? I don't think they're bad omens, just to be clear. I like them and respect them very much. I just think it's interesting that they saw them and wanted their teeth as jewelry. Feels a little bit heinous. There was also a very large flightless bird that was alive in Madagascar, the elephant bird. Very fitting name, very straightforward, to the point. They were fucking massive. The largest got to 10 feet tall and over 1,600 pounds, making them the heaviest birds to ever exist that we know of. They went extinct sometime between the years 1200 to 1700, likely due to habitat loss, possibly a disease from chickens. A similar bird was alive until around a similar time, but this time in New Zealand. Allow me to introduce you to the moa, who had legs like nobody's business and lost their wings entirely. No wings at all. The largest were about the size of an average elephant bird, 6 feet tall, and range in size from 40 to 500 pounds. Very wide range. Also, with their necks fully stretched out, they could reach foliage about 12 feet off the ground. Very slinky. And like I said, they had no wings. Zero. Not even vestigial wings. They went places carnivores could only ever dream of. But unfortunately, the life histories that made these birds the icons they were is part of the reason they couldn't survive. They reached their size by growing slowly over their long lifespans. Gave birth to very few babies. Two factors that make it very difficult to repopulate in desperate times. Around the year 1200, a population of Polynesians settled in New Zealand, saw the moa as a convenient way to feed their group. Understandable. But within just 300 years, this massive bird, which initially had a population of like 58,000 individuals on the island, had been completely wiped out. Around this time, many other groups of people were exploring the world in historic, but also destructive ways. Spanish conquistadors were expanding their territories in the Americas, Christopher Columbus, etc. There were also new understandings of our place in the universe. Galileo, Copernicus. Our planet revolves around the sun. Also during this time, the wild ancestors of modern cattle were becoming increasingly rare. The aurochs, absolutely massive beasts that were first domesticated over 10,000 years ago. They got to about 5.5 feet tall at the shoulder and were found all throughout Europe. Males had huge, forward-curving horns, which make me question how the fuck they domesticated them in the first place. When they reached their lowest numbers, Europeans turned them into a symbol of royal privilege for hunting. By the year 1627, the last few were hunted to extinction. This is another animal on the de-extinction list, by the way. The scientists actually started working on like 100 years ago. Today, the biggest group working on this is the Taurus program in the Netherlands. Their method is called backbreeding, where they crossbreed domestic cattle with characteristics similar to aurochs in hopes of creating auroch-like creatures to reintroduce into multiple rewilding sites across Europe. The next one on the list is actually one of the biggest icons of extinction and the de-extinction efforts. The dodo, the beloved laid-back bird that lived on the islands of Mauritius until the 1600s. They got to about 3 feet tall and 40 pounds, and lived carefree on the island where they didn't have any natural predators. They were slow-moving, unsuspicious. As you can probably already guess, this made them very easy targets for sailors that arrived in the 1500s. These sailors also introduced rats, pigs, and monkeys that fucked up the paradise the dodos were used to. And all of this combined turned them into probably one of the most devastating cases of recent extinctions. But like I said, they are on Colossal's de-extinction list. So I'm going to talk about that plan when I do the Colossal video, so stay tuned for that. Also, notice how I have plans for after this series is done. I know a lot of you are upset that the series is over. But I got plans, bitch. I'm not going anywhere. During this time, up in the north, near Russia, lived the stellar sea cat, a giant relative to the dugong that got to about 30 feet long and 20,000 pounds. They were very big and very cute and lived in shallower waters, kind of like manatees today. They were first discovered in 1741 by George Steller, hence the name Steller sea cat, and he studied them by himself until they went extinct only 27 years later. During that time, he noted they were really social, living in small family groups that vocalized through heavy breathing sounds and sighs. They liked to eat kelp and seagrass and use their prehensile upper lip to help them grab at it. Around the time that they were hunted to extinction, there were many wars and other depressing shit. And I know this video is getting a little depressing as well. There's a few more I want to introduce you to, and you can safely assume humans are the reason they went extinct. I don't want to keep repeating that. The Great Auk, alive until 1844. A few years before the California Gold Rush, and also around the time the word dinosaur was invented. They were like the penguins of the north. Flightless birds alive from the North Atlantic, from like Canada all the way to Denmark, potentially to the west coast of Russia. They're about 2.5 feet tall and lived lifestyles similar to penguins, diving to eat fish and thriving in the cold. They were actually the inspo for the common name penguins of the South have today. They're not related, it was just inspo. The Great Auk belonged to the genus Penguinus. Birds in Antarctica looked like penguinus, hence the name penguins. Another cool bird, the Haas eagle. Originally thought to have gone extinct about 700 years ago, but potentially existed until 1860. Let me explain. They were the biggest eagles to ever exist, that we know of, with wingspans of 8 to 10 feet long. They were apex predators in New Zealand, and are thought to have even been predators of the moa, even the big ones, which is nuts, swooping down from trees or cliffs to catch and kill their prey with their powerful talons. They were first described in 1871 as an extinct bird. Like I said, extinct for like 500 years at that time. But in the late 1860s, a European explorer named Charles Douglas shot 2 large hawks, which fit the description of the later described Haas eagle. Did Charles Douglas shoot the last 2 Haas eagles before they had even been discovered? Probably not, but you never know. And another cool bird, the passenger pigeon. They're found all throughout eastern and central North America. Kind of looked like mourning doves alive today. You know, the ones that have those lovely calls in the morning that probably remind you of walking to school. I have a view of a lovely tree outside, and they like to sit in it. It's their favorite place to sit. So I see them all the time. I'm very happy about it. The passenger pigeon kind of looked like them, a little bit bigger, and a lot more abundant. Abundant is an understatement. It's thought that a few hundred years ago, their species alone made up 25 to 40% of the total bird population in the United States. 3 to 5 billion individuals with a B. Absolutely nuts. So as you would expect, they had a huge impact on their ecosystems. They would nest in colonies of millions of birds, taking up like 10 square miles of space, and that was just the typical. One of the larger sites was thought to be about 850 square miles in Wisconsin, and was thought to have about 136 million birds. They were North America. If the world was a dictionary and you went to North America, the picture of it would have been the passenger pigeon. They went extinct in 1914. I don't think I have to paint a picture of how it went down. But considering how many there were and how quickly their numbers crashed, they kind of became a poster child for the need for conservation laws. That became the silver lining of this extinction. More people became really strong advocates for wildlife conservation at the time. And because of this, countless other species have been protected since then. I have one more I'm going to introduce you to, or I guess reintroduce you to, because I'm sure they don't need an introduction. The thylacine, also known as the Tasmanian tiger, a carnivorous marsupial that went extinct in 1936. Another weird-ass marsupial, dude. It had its own copycat version of another carnivorate. This time, looks like a dog, but still off in that marsupial way we know and love. Here are my thoughts on them. They shouldn't be extinct, but they look extremely prehistoric to me. If I knew nothing about them, and someone showed me an artist reconstruction of them, and asked me to guess what time period they existed in, I would probably assume Eocene, Miocene. They're giving hyenodon. They're giving weird 30 million years ago. But they went extinct less than 100 years ago, and there is actual video footage of them. Rather than focus on their extinction, I want to talk about what we know about their existence, like we have with all the prehistoric animals throughout this series. Despite looking like a dog drawn by someone attempting to draw for the first time, the thylacine was really cool. They had those half-erased stripes across their backs, hence the name Tasmanian tiger. And just like other marsupials, they had pouches, and not just the females, males too. That's pretty unusual, but they weren't used the same way. Females had them to carry their joeys, males had them to protect their reproductive organs. For the males, it was a pseudo pouch. In sources from the 1800s, there's a couple times authors have kind of implied that the thylacine could periodically hop like kangaroos, using the word bound. In 1835, Henry Melville noted that when running, the thylacine bounds like a kangaroo, though not with such speed. Another author wrote, it has some of the peculiarities of the kangaroo. for it proceeds by bounds. What the fuck did bound mean? Kind of implies kangaroo hopping, but later studies of their anatomy don't show any ability to do that. Maybe it meant something else. Maybe more like a bunny. Who knows how much lead poisoning was fucking up their perception of reality back in the day. Despite slanderous rumors back in the day of drinking blood and hunting livestock, it seems as though the thylacine preferred smaller prey. Bandicoots, patamelons, and other Australian named things of that nature. They were ambush predators that hunted at night, relying on sight and sound for hunting more than smell. They were absolutely darling. I hope we get to see them with our own eyes if the de-extinction technology works, which is going to be used in many ways, reworking it to focus on endangered species and the crises that we face with the mass extinction today. Because yes, we are facing a mass extinction. You might be tempted to turn this video off now, but do not move a muscle. You're not allowed to leave yet. I'm not ending this series on a bad note, I promise. Just give me a chance, hear me out. Also, I want to give a shout out to my friend Heidi, who's a climate activist. She helped me figure out the right way to end this video. Many thanks to her, and go check out her channel. Humans are obviously very special evolutionarily. We've created tools and technology that no other being has been able to, ever, that we know of. We've figured out how to create energy using stored carbon that existed in life forms that were alive in the deep past. The remains of plants and animals that we've talked about in this series were buried, and with heat and pressure over millions of years became coal and oil and so on. And we figured out how to tap into it and use it to advance. Objectively, that is fucking cool. For the health of the carbon cycle, not so cool. Carbon is the backbone of life on Earth. You're made of carbon. Your dog is made of carbon. Your plant and the mold you can't get rid of, made of carbon. It's stored in mountains and is occasionally released via erosion and weather it then seeps into the soil. It is also released into the atmosphere from the oceans and plants and microbes. That's the carbon cycle. Shit cycling around. And the burning fossil fuels fucked it all up. But when it happened, we didn't know. All we knew is it was allowing us to advance, survive in places that would not normally be survivable. And in that growth, we flew too close to the sun and released a lot of nasty shit in the atmosphere that didn't need to be there. Now it feels too big to tackle. The story of this epic is the development of us, which has been unbelievable compared to everything else we've talked about in this series. But it's had a lot of downsides. Like any natural ecosystem, all of our human activity is intertwined. Fossil fuels being pumped into the atmosphere, expanding society into natural habitats, moving animals around to places they shouldn't be, etc., etc., etc. These systems have been developing for hundreds, if not thousands of years. And now, for the first time in the history of life on Earth, that we know of, we are given the task to fix it. That is an extremely heavy weight to carry. That feels almost impossible. It doesn't help that a lot of the coverage on this topic is shit is getting really bad, we need to fix it. And then boom, curtains close, show is over. That would make anyone feel completely hopeless and shut down and try to avoid talking about it, and that's understandable. I think what we need is a shift in perspective. I have realized, especially in the last couple weeks, that sometimes when a problem feels too big to fix, and the steps you have to take to fix it feel too much to take on, all you have to do is try reordering the steps, reordering the priorities, when sometimes that's just not possible. The problems intertwined with this mass extinction and our changing climate are huge. No one person can take them on, but they are built by smaller units that are much easier for one person or one group of people to tackle. Let me give you a couple examples. Of course, I'm going to start with the Cheetah Conservation Fund, which was founded by Laurie Marker in Namibia in 1990 to help save the cheetahs from extinction. Most wild cheetahs alive today are in Namibia. And like many animals, the reasons for their decline are complex, include human-wildlife conflict, habitat loss, human settlements expanding into their territory, farmers shooting them to protect their livestock, people illegally trafficking them to be sold as pets in other countries, thornbush habitats taking over open grasslands that cheetahs need to thrive. That all feels like a tangled mess, but CCF has managed to find a solution for all of those problems over time. To tackle the issues of farmers shooting cheetahs to protect their livestock, they started raising Anatolian shepherds to be livestock guarding dogs. Boom. Cheetahs are naturally afraid of any predators larger than them, so they choose flight over fight. So CCF raises those dogs, brings those dogs to farmers near cheetah territory, and the dogs are able to protect the livestock by scaring away the cheetahs. Nobody gets hurt. It's a win-win. For illegal trafficking, they work with the Namibian government and have a location in Somaliland, which is a big hub for the export of cheetahs, to stop the traffickers before they take them out of Africa. Then they care for all these rescued cheetahs and release them back into the wild through a very lengthy behavioral process whenever it's possible. And for the thorn bush, they created a new business model. Harvest the thorn bush out in the wild and process it into a high-heat, low-emission, compacted log that can be used as fuel. This restores the grassland habitats, provides a whole new job market in Namibia, and provides another source of sustainable energy for the region. Sick. And all of these programs, which are just the surface level of what CCF works on, have been able to stabilize and even started to increase the cheetah population in different regions in Namibia. That is fucking sick, dude. People identify solutions to problems and then continue to build more solutions to those problems, and it adds up. And there are people doing these kinds of projects with different focuses and different scales all around the world. Another one, the hole in the ozone layer. Back in the 70s, people used a lot of air aerosols, and then we figured out it was creating a hole in the ozone layer. That is a bad hole. The ozone layer is important, protects us from UV. Countries came together and created the Montreal Protocol in 1987, and now the hole is shrinking, and it will be completely shrunk in the coming decades. I know it feels like people don't get shit done a lot of the time, but we do. We get a lot of shit done. Humans have really been altering their ecosystem since the agricultural revolution, like we talked about before. And over time, the scale and severity of our impact has increased exponentially. But shit was going business as usual. We had no idea until like a little over 100 years ago. We're figuring shit out. One thing about our species is we are very good at adapting and innovating. We are inventors. There are solutions to these problems happening all around us, and they are completely accessible for you to be a part of. You don't have to create a new source of energy to change the planet. You don't have to save a species from extinction. Look at your community. Look at the lakes or ponds nearby. I know it sounds cliche, but genuinely, change happens there. Shit got bad starting in those small communities, and that's how you make it better, is starting in those small communities. I guarantee there are ecology groups or conservation groups nearby that you can volunteer with. And maybe they're not totally in line with what exactly you want to work on, but it might send you in directions you can't even imagine right now. I 100% credit my desire to start learning about the world and eventually teaching to my time at CCF, which I found out about by volunteering at a wildlife rescue near my college. The world works in really weird ways. Getting involved that way locally could also give you a whole new community to be a part of. That's really nice. One thing these fires has made me realize firsthand is that we function really well as a community that has a common goal. The support for victims of the fires was felt throughout the city almost immediately. Shelters have been turning away donations because they received so much more than they needed. Places were overflowing with people wanting to volunteer to help in any way they could. We really care about each other and show up for each other. We have our flaws. There's no denying it, but we are a very cool species. Yes, we have done some serious damage, but we've also realized that we're doing it in the first place. And we've learned so much about our planet. No other species knows this much about our planet that we know of. And we know about our deep past. That's nuts. And that collective knowledge and our continued desire to learn has allowed me to create this series to present to you wherever you are in the world and make us feel connected while doing so. Thank you for watching. Creating this series has truly been one of the most unbelievable experiences of my life. I am so grateful to have been able to do it, and I'm so grateful that you have been along for the ride. In the intro to this series, I mentioned that learning about the history of life on Earth has helped me with my own existential anxiety. Understanding where we came from really helps me feel comfort in not knowing where our planet is going. There's a chance you resonated with that, and so, if you made it this far into the video and this series, I have a little secret to share with you. Before I ever started making long-form videos on this channel, I used it to upload videos of songs that I wrote. This channel is very old, but using it for animal content is new. Once I switched the theme, I privated all of them, and I totally forgot until a couple weeks ago that I had uploaded a video of a song I wrote about my existential anxiety when I was 19. It's called Bring Me Peace, and I still play it on my guitar a lot. It's one of my favorite songs I've ever written. It's really short, but I decided to make the video unlisted so you can watch it if you have the link, which I put at the very bottom of this video's description. Once you click on the link, the lyrics are included in that description in that video. Thinking about that song and the lyrics and where I'm at now, especially after finishing this series, it's crazy how dramatically my mindset has shifted since learning about evolution and finding comfort in that. Pretty much every line of that song does not feel true for me anymore. So I guess I wanted to share it with you because, one, I wanted to show you some of my music, and two, maybe it'll provide comfort if you are struggling right now. I wrote that song 8 years ago, and since then, I've found this passion in the natural world and learning more about it. And it has fundamentally changed my life for the better. The world is constantly changing, and we are constantly changing too. Our mindsets will never be stagnant, and that is really cool. So what now? Now that the series is over? Well, things are gonna continue business as usual. I'm gonna take a little break, like 2 or 3 weeks, because while I did love making this series, it did take a lot out of me. But I'm setting it up so you don't really notice a big gap. It's not going to be noticeable at all. And now we're just going to keep talking about a lot of cool shit. Cool prehistoric species that should be expanded on. Cool species alive today. Heinous, disgusting creatures. All the usual shit. I've mentioned a couple series I have in mind. The history of cats. Maybe the history of rats. A de-extinction video. Other things that I would love to hear your suggestions on. And I definitely want to start traveling more. Going to sanctuaries like CCF that are doing really cool work, but also just traveling for fun. Maybe I'll go visit some national parks and camp for a bit and film random shit while I'm out there that has nothing to do with the national parks. I was kind of thinking it might be fun to like bring something like this. Like I can work remote, so I can just go somewhere and set this up. Maybe do a video about anglerfish while I'm in Yosemite. I don't know. We'll see. I have plans. And now, if you didn't have it before, this series kind of gives you like a prerequisite collection of information to keep in mind as we talk about Paraceratherium, Opabinia, any animals alive today. Now you kind of have some idea of their deep history. I hope you're excited. because I am too. So make sure you subscribe so you don't miss any of it. Check out my Patreon to keep up with behind the scenes updates in our Discord server. And for now, stay curious. The world has a lot for us to learn. See ya!